MAP kinase or MAPK signaling pathways have a broad influence on cellular behavior and responses. Within the MAPK family, there are several different proteins or central kinases, including the JUN, P38, and ERK1/2 families. The ERK1/2 families seem to have most importance to the development of dependence. Generally, the MAPK signaling pathway is recruited by the beta-arrestin-bound mu-opioid receptor complex. So this is when the mu-opioid receptor has been phosphorylated and the beta-arrestin has been recruited to that site of phosphorylation. As you can see here, the MAPK kinase pathway is recruited by the activation of PLC, which in turn activates the kinase, protein kinase C, which then activates the MAPK pathway. Alternatively, the pathway can be activated by protein kinase A, which is derived from the AC-CAMP pathway discussed previously. Studies have shown that inhibiting MAPK action, especially inhibiting ERK1/2 action, can reduce withdrawal-like behaviors in preclinical models. We call these agents MEK inhibitors, meaning MAPK/ERK inhibitors, because the mechanism of action is primarily at the site or on the ERK proteins. Indeed, the injection of a MAPK kinase inhibitor to the central amygdala has shown the ability to reduce anxiety as well as reduce withdrawal. This could be a promising site for targeting to improve mood without risking addiction or dependence developing. So why do the ERK pathway and why do MAPK kinases in general contribute to dependence? Well, as you can see on this slide, for specifically the ERK proteins, they induce a type of plasticity. Plasticity being the change in neuron structure and function thought to underlie changes in learning and memory. In particular, the activation of ERK1 or 2 has been shown to activate CREB. CREB is a protein known to mediate structural and functional changes between neurons. In other words, CREB changes the connections between neurons and thereby changes the learning and memory in a person. In this particular context, the changes in plasticity driven by CREB, which itself is driven by ERK activation, seems to lead to craving and addictive behaviors, at least in the hippocampus. Indeed, by inhibiting this pathway upstream through the RAC1 receptor, so by using this agent SHGNB2LI to inhibit RAC1, we can decrease the activity in the overall pathway and therefore prevent this plasticity from developing.